This is the second video where we're going to factor using the AC method. And of course, if you haven't watched the first video, you'll need to do that first, because here's your first problem. Factor this using the AC method. First, I need to find the product AC. In this case, it's 1 times 36, which is 36. And I notice the value of B is 15. Next, I have to generate all factor pairs of 36, and I do that using the prime factored form. The factor pairs for 36 are 1 times 36, 2 times 18, 9 and 2, 3 times 12, 4 and 3, 4 times 9, there's no factor of 5, and 6 times 6 will be the last pair I have to worry about. Next, I look through my pairs and try to find one which might add up to 15. Here's a pair that would add to 15. Now I need to check if that pair meets both criteria. That is, the product needs to be the same as A times C, and 3 times 12 does give us 36. And when I add them, I need to get the value of B, and 3 plus 12 does give me 15. So you should always make sure both criteria are met by your factor pair. Now I return to my original trinomial. The second degree term will remain the same, the constant will remain the same, but the 15h will be written as two like terms using my factor pair as coefficients. It'll be h squared plus 3h plus 12h plus 36. I factor by grouping, and then I check whether I get my original trinomial back. This will give me h squared, 12h and 3h will give me 15h, and 3 times 12 will give me 36. The answer looks good. Here's the next one. First, I need to write in standard form. A is 1 and C is negative 40, so A times C will be negative 40, and B will be negative 3. My prime factored form will be 8 and 5. And here are my factor pairs. That is, 1 times 40, 2 times 20. There's no factor of 3. 4 times 10. 5 times 8. Since there's no factor of 3, there can't be a factor of 6. And there's no factor of 7. I now look for a pair which might add up to negative 3. This one would, but only if the 8 is negative. I now make sure both criteria are met. 5 times negative 8 does give me negative 40. 5 plus negative 8 does give me negative 3. So I can return to my original trinomial. The second degree term and the constant will remain the same, and I'll rewrite the first degree term using these two values as my coefficients. That is, it will be b squared plus 5b minus 8b minus 40. I'll continue and factor by grouping. And then I'll check my work. B squared minus 8b plus 5b will be minus 3b. And then 5 times negative 8 will give me my negative 40. Here's our next one. In this case, A times C will be negative 60, and B will be positive 17. I'll get my prime factored form, and here are my factor pairs. 1 times 60, 2 times 30, 10 and 3, 3 times 20, 4 and 5, 4 times 15, 5 times 12, 6 times 10, no factor of 7, no factor of 8, no factor of 9, and then I get to 10, and I'm starting back again, so I have all the pairs I need to worry about. Now I need to find a factor pair that might add to 17. But notice in this case we have two of them. 3 and 20 could add to 17 if the 3 was negative and the 20 was positive. 5 and 12 could also add to 17 if they were both positive. So now I have to decide which pair is the right one. Notice that for this to be the right pair, both the 5 and the 12 would have to be positive. But 5 times 12 gives us a positive 60, not a negative 60. On the other hand, this could be a 17 if the 3 was negative and the 20 was positive. Negative 3 times 20 would give us negative 60, and negative 3 plus 20 would give us 17. So that's going to be the right pair, as long as I see it as negative 3 and positive 20. I then return to my original trinomial. The second degree term and constant remain the same, and so I have q squared minus 3q plus 20q minus 60. Now I factor by grouping, and then to check my factored form, I would distribute and get q squared plus 20 minus 3 would be plus 17q minus 60. And here's our last one for this video. In this problem, a times c is 28 and b is negative 16. The prime factorization of 28 is 4 and 7. And so my pairs will be 1 times 28, 2 times 14, no factors of 3, and 4 times 7. The pair that might add up to a negative 16 is 2 and 14, but only if both are negative. I then make sure both of the criteria are met. Negative 2 times negative 14 does give me positive 28. Negative 2 plus negative 14 gives me negative 16. So I'll rewrite my trinomial as a squared minus 2a minus 14a plus 28. After factoring by grouping, I can distribute and find I have a squared minus 14 minus 2 is minus 16a, and negative 2 and negative 14 is 28. Well, that concludes this video where we practice the AC method with the value of a being a 1.